Good morning and welcome back to Intermediate Algebra. We have just a few problems to finish related to mixture problems, and then we're done with our Unit 2 notes. So let's take a look and yeah, let me know how this actually goes as you review the videos, which I'm sure you will. Okay, let's check it out. Charisse is the owner of a Starbucks coffee shop. She sells blonde roast coffee for $6.20 per pound and pike roast coffee for $5.80 per pound. If she uses 18 pounds of the blonde roast, this is something we should definitely be highlighting, in the mixture of these types of coffee and sells a blend for $6.10 per pound, how many pounds of the pike roast coffee, so this is what we're trying to find out, how many pounds of the pike roast coffee should she mix with the blonde roast coffee? So what may be helpful to us in terms of designing these mixture problems is I like a graphic organizer. I really do, especially for these types of problems. So I'm going to almost treat this like buckets. So as a reminder, when we talked in class, we described what value meant, right? In the sense of purchasing an item and the things that you need to know in order to actually make that purchase. So in class, we talked about Honeycrisp apples. And we said, well, how much would you have to spend if I asked you to buy 10 pounds of apples, right? Maybe I'm making a ton of apple pies. And we know that the Honeycrisp apples are $2.79 per pound. Well, you knew when we were having this discussion that to find value, you would take the cost and you'd multiply it by its amount. So cost per unit times the number of units. And that's exactly what we're going to be doing here when we create this mixture problem. So we're looking at each item or each ingredient, and we're considering what's the cost per unit, how many units that we can actually create a value equation. So as a reminder, we are looking at systems of equations. So maybe we'll build a system, maybe we won't, depending on how much information is given. We have options here, and I want you to feel comfortable kind of building these problems. So we're going to see three that are a little bit different in variety, and I think that will be very helpful to you. But let's dig into this one a little bit deeper. So in order to set this up, I'm actually going to create these like boxes. And I notice that I'm mixing two ingredients together to make some amazing coffee mixture. The ingredients that we're mixing together are blonde roast coffee and pike roast coffee. So those are the two ingredients that I'm mixing together to come up with this amazing coffee mixture. Now, I'm going to go through and make note of information that I have. So we are told that blonde roast coffee sells for $6.20 per pound. So this is the price per unit. So that's actually interesting. And if I so choose, I'm going to keep the cost, right, per unit in the upper half of each box. So blonde roast is $6.20 per pound, right? I'm going to put a little check mark here. We know that pike roast sells for $5.80 per pound, so that's the unit price, $5.80 per pound, amazing. Then we see that she uses 18 pounds of the blonde roast coffee. So we know specifically the weight, right, of just blonde roast. So I'm going to put here weight, and the weight is in terms of pounds. You see how I'm organizing myself as I move through? So we're going to put 18 pounds here in the lower half of my box. So I'm kind of organizing this in terms of ingredients. Now, we are told that the mixture of these types of coffees sells for $6.10 per pound. So now we know the unit price of the mix itself. There we go. Okay, this is amazing. We have a lot of information here. Now we have to figure out how many pounds of the pike roast coffee. Well, I don't know. So I'm going to use P for pike roast coffee. Should she mix with the blonde roast coffee? That means we actually don't know the total weight either. We know there are 18 pounds of blonde. We know there are P pounds of pike. So if your heart desires, you could simply write 18 plus P, right? Because it's blonde plus pike. Or I can say it's a mix. And I don't know what's in the mix, but I'm going to call it M. Now, this is where we have an opportunity to construct two equations. The first thing I want you to consider is when we look at just weight here, we see that we have 18 pounds of the blonde roast plus P pounds of the pike roast equals M pounds of the coffee mixture. So that's actually one equation in and of itself. So I'm actually going to go ahead and highlight straight across as a reminder that this equation here deals with weight. Weight plus weight equals total weight. Now, it would not make sense to say 620 plus 580 equals 610 because that's just simply not true. Additionally, there are no variables here. So now we have to get creative. The second equation we have to remember deals with value. And as a little note here, and as a reminder, value is going to be the cost per unit multiplied by the number of units. In this case, that means the cost per unit or per pound times the number of pounds. So what we're going to do here is we're going to find the value of blonde, then I'm going to add the value of the pike, and then I'm going to set it equal to the value of the mixture. So our yellow highlighted equation deals with just weight, and our orange highlighted equation will deal with just value. So value is cost times weight. So 620 times 18, I'm going to go ahead and punch this into my calculator. $6.20 times 18, right? That's $6.20 per pound. You bought 18 pounds. So altogether, that's going to cost you $111.60. And then I'm going to add that to the cost times the weight. We don't know the weight, but that's okay. Whatever this weight is, we're going to multiply it by 580 per pound. So this is going to be 580p. And that's going to be equal to, again, cost times weight. So 610 times M. Notice here we have a cost equation, meaning value. So we have a value equation and we have a weight equation. Because of that, we actually look at this system and we can say, you know what? This is perfect for substitution. We already know that M is 18 plus P. So I'm going to take this information, this 18 plus P, and I'm going to substitute it in for M, and then I'm going to solve. So I have 111.60 plus 580p is equal to, now we're going to rewrite this as $6.10 times 18 plus P. If you had, instead of written M, you had written 18 plus P, you'd be here. You would say 620 times 18, 580 times P is equal to 610 times 18 plus P. So that would be if you didn't want to write a system of equations and you simply wanted to write an equation in one variable, and that would be totally okay. But anyways, let's continue and solve. So we have 111.60 plus 580p. We're going to go ahead and distribute this 610. So we have 610 times 18. That's going to give me 109.80, because remember, I'm talking about money still. So I like to look at things in terms of pennies, right? $109.80. And then, of course, don't forget to distribute the 6.10 to the P. Beautiful. I'm going to go through this process and solve, and then I'll reveal the video in just 1 second. Okay, and here we have our solution. So we brought over the 580. Always move the variable terms first. It's going to make life a lot easier. I moved the smaller variable to the larger, right, in terms of their coefficients. And then, of course, I brought the 109.80 over to the left, so that way I can isolate the term with P on one side and then isolate the constant on the other. In order to solve for P, I had to divide by its coefficient, which is 0.30. I did that to both sides, and I find that P is equal to 6. That means we can finally answer this question. The question is, how many pounds of the pike roast coffee? Well, you can say 6 pounds of the pike roast coffee. And that would be the answer to your question. If it asks how many pounds were in the mixture, well, that's easy. You have 18 pounds of blonde roast, 6 pounds of pike roast, and then 18 plus 6 means that there would be 24 pounds total. So something to think about. The layout of this graphic organizer is really helpful because it allows you to answer all of those kinds of questions, and it's a very visual representation of the problem itself. Let's turn the page and take a look at another one. Okay, Laura Hernandez Espinosa, a well-known Latin sommelier, chooses to combine two red wines. She mixes 5 liters of a Shiraz. I'm going to go right ahead and highlight because this is information that goes together. So she mixes 5 liters of a Shiraz, that is 12% alcohol by volume, that goes together, with 2 liters of a Pinot Noir, that is 9% alcohol by volume. That's a lot of information. So the last thing we have to do is we want to determine the alcohol content of the mixture. Same exact idea here. We're going to go ahead and set up our boxes. We know that we're mixing 2 ingredients together. That is Shiraz and Pinot Noir. Those are our 2 red wines. I can write. And Pinot Noir. And that's going to be equal to our mixture. So being careful, let's organize our information. We know that the Shiraz is 5 liters and it's 12% alcohol by volume. It doesn't matter which side of the box you place this information as long as you're consistent. So I'm going to call I don't know, for the sake of doing, I always like putting the weight at the bottom for some reason. So I'm going to put liters in the bottom. So we know that we have 5 liters of Shiraz. And then I'm going to put the percent alcohol by volume at the top. Percent alcohol. Now keep in mind, you cannot leave percentages as percentages. You must convert to decimals. So as a reminder, 12% as a decimal is 0.12, and that is because you take the 12, divide by 100. Similarly, 9% alcohol is going to be 0.09. Take that 9 divided by 100. So let's fill in our chart. We see that Shiraz is 12% alcohol. Pinot Noir is 9% alcohol. We also know that we have 2 liters of Pinot Noir. And then we actually do not know the alcohol content of the mixture. So we're going to call that M. I have no idea what that is. But I do know the amount in this mixture. If I'm mixing 5 liters of Shiraz and 2 liters of Pinot Noir, that means altogether, you guessed it, I have 7 liters of my mix. The amazing thing about this particular problem is we only have one unknown. Because we have one unknown, we only need one equation. Now, it would not make sense to say percentage of alcohol plus percentage of alcohol equals total percent of alcohol. That is not what's happening here. I want you to think about this logically. Think about juice concentration. Do you remember as a kid, we had those little frozen cartons of like concentrated juice, and you had to peel the cardboard and pop that little tub, and then you poured it into this like bucket, right? This like little jug or whatever, and then you had to fill it with water. The reason you filled it with water is because you had to dilute that concentrated juice. If you tried to just allow that concentrated juice to melt and then drink that, it would be probably the most disgusting thing you've ever done. It would probably be so tart and disgusting. You'd be like, right? It'd be nasty. So you have to dilute it. And what happens is when you add that water and you are diluting it, that concentration is being diluted as well. So I want you to think about that with mixtures, right? So for instance, if you have a really strong alcohol and you're mixing it with a weaker alcohol and you put them together, you're going to get a concentration that's somewhere between those two because a weaker alcohol is diluting the stronger one. So it can never be stronger than the strongest. That wouldn't make sense, right? Because you're actually diluting it. And it wouldn't be weaker than the lowest one or the weakest one because you have a strong alcohol here. So it's somewhere in between. It's a nice combination of the two. So to say 0.12 plus 0.09 equals M makes no sense at all because that's absolutely impossible and that's simply not the real world. So what we're doing instead is we're thinking, well, that's not going to work. I already know the weights, so I must be dealing with value. Remember that value is not only cost times amount, it's actually concentration times amount. Same exact idea. So you're literally saying, well, what's the percentage of alcohol and how many liters did I use? Multiply that together. That's a value. We're going to do that for Shiraz, for Pinot Noir, and for the mix. Check it out. And we'll only need one equation, which is actually really dope. So I'm going to write this as the value equation. So that means I'm going to go ahead and circle it. We're going to take 0.12, multiply it by 5. We're going to add it to 0.09 multiplied by 2, and we're going to set that equal to m times 7. It's the combination of these. So 0.12 times 5, I'm just going to do the math. I prefer to just type that in. That's going to give me 0.6. Plus, then we have 0.09 times 2. That's going to give me 0.18. And then, of course, m times 7 is just 7m. One equation, that's all we need. Let's add these two terms together. That's going to give me 0.78 is equal to 7m. And then lastly, we divide by 7. So 0.78 divided by 7 is going to give me 0.111428, right? Now, I want you to notice the alcohol content is in terms of integer values, so 12%, 9%. So if I multiply this by 100, I get 11.1428 percent. So I'm going to round my answer and say the alcohol content of the mixture is 11%. I'm going to round to the nearest percentage, especially because that's what we see here with the 12, and that's what we see here with the 9. Amazing. One more problem to take a look at, and that is how many liters of a 20% acid and a 70% acid must be mixed to get 50 liters of a 35% acid. This is classic. This particular problem where you're mixing two ingredients and you don't know the quantities of either is classic. This is something you'll see again and again and again, right? There are some special problems where maybe you have an ingredient that's pure alcohol or pure water or something like that, and you have to get creative with those. I do have extra videos covering those topics, so please feel free to check those out. They're in my 098 playlist under mixture problems or mixture applications. Check those out. They're a lot of fun and very interesting. But let's take care of this problem. All right, let's set up our boxes. It doesn't matter what we call these. I might actually consider this as like this 20% acid is my acid number 1. So I can call it acid number 1 here. That may be helpful. And then, of course, we have a 70% acid. So I'm going to call that my acid number 2. Let's call that number 2 here, acid number 2. And we're trying to get 50 liters of a 35% acid. That is definitely our mixture, right? How many liters of this and that must be mixed together? So these two are being mixed together to get 50 liters of a 35% acid. So here's our acid mixture. All right, let's put in our information. The top row of each box, I'm going to call the percent of acid. And we want to know how many liters of each. So the bottom row of each box is going to be liters. We have a 20% acid, 0.20. We're mixing that with a 70% acid. So a weak acid with a really strong acid. So we should expect that the mixture should be somewhere in between these percentages. And guess what? It is. So our mixture is 0.35 or 35% acid, but we also know that we want to have 50 liters of the mixture. So I'm going to put 50 here with the mixture box. Now, that means we do not know either of the amounts. So let's just call this capital A, and then we'll call this capital B. Perfect. Now we get an opportunity to write two equations. We know that because we have two unknowns. Just like our previous problem, we're going to make note of our weight equation, and that is A liters plus B liters equals 50 liters. So that's our first equation. A plus B is equal to 50. My second equation, you guessed it, is going to be value. So concentration times amount plus concentration times amount equals concentration times amount. So we have 0.20 times A, which is 0.20A, plus 0.70 times B is equal to, and now I'm just going to punch this in, We have 0.35 times 50, and that's going to give me 17.5. Now, this system is perfect for elimination, and that's exactly what I'm going to do because I love elimination. So out of these two variables, I'm going to choose to eliminate A because it has the smaller coefficient. I prefer to do that. That way my values tend to be more positive. I am going to do that by multiplying our top equation by the opposite coefficient, which is a negative 0.20. Make life easy. Just go ahead, multiply by that opposite, and then, of course, don't forget to distribute. And this is going to leave me with negative 0.20a minus 0.20b is equal to, now let's take that negative 0.20, multiply it by 50, and that's going to give me negative 10. Bring the second equation straight across. Da, da, da. And then we are going to combine in column form, right? We learned how to solve systems of equations. These two terms will cancel each other out. That's completely gone. If you punch into your calculator, negative 0.20 plus 0.70, you're going to get 0.50b. And then if you plug into your calculator, negative 10 plus 17.5, you're going to get 7.5. Last step is to divide by 0.50. So we have b is equal to, let's punch in 7.5 divided by 0.50, and that's going to leave me with 15. Immediately, I'm looking back in my chart and I'm seeing that B is the number of liters of acid 2. So I just found that 15 liters is the amount of acid 2. Super cool. I still need to find A. I have two equations, so I'd actually prefer to use the first one, right? And that is that the sum of these liters is 50 liters. So let's plug B into the first equation. So we have A plus B is 15, is equal to 50. And now all I have to do is subtract 15. Once I subtract 15, I find that A is equal to 35. And now I can answer my word problem. And that is, we have 35 liters of the 20% acid. I'm being careful here because the problem did not say acid 1 and acid 2. I labeled it acid 1 and acid 2. So now I'm being very specific and saying 35 liters of this acid. And then, of course, 15 liters of the 70% acid. And just like that, we're done. Amazing. I hope that this was incredibly helpful to you. Play around with these problems, try the graphic organizer, and I will see you all next class. Bye.